So we just finished our unit covering trig functions, sine, cosine, tangent, and one of the major parts of that unit was the idea that we can't use those trig functions unless we have a right triangle. Well, I'm here to tell you now that that's not 100% the truth. There are instances where we can use those trig functions without a right triangle, but we can't use them in the same way. Those relationships between the sides no longer exist unless we have a right triangle. So, in these next couple of days here, you guys are going to watch some videos on how can I use the sine function or the cosine function when I don't have a right triangle. The fact is they have specific laws, and these laws do not necessarily indicate anything about opposite, hypotenuse, or adjacent sides. So I want you guys to pay attention as to when we can use these and how we can use these. And one of the major things you're going to have to do is look to see how you use your calculator. Putting things into your calculator is going to be a major skill. So today's video is going to focus on the law of sines. We're only going to be using our sine function in today's video. And there's two circumstances that we can use the sine function if it's not a right triangle. The first one is when you know you've been given two side lengths and the measure of one of the opposite angles, and you're looking for another angle measure. An example of that would be here. I have this angle measure that I'm looking to find, but I know this angle measure, 115 degrees. That's something I know. I know this side length is 49, that's one side length, and I know this side length of 16, two side lengths. I'm looking for another angle measure. The second situation is when you know or you are given two angle measures and one side length, and you're looking for a new side length. One of the major things that you're going to deal with here is the fact that as long as you know two angle measures, you actually know all three, because you can use the triangle sum theorem to find that third angle measure. In this particular problem, you know you have a 48-degree angle and a 22-degree angle. Triangle sum says these three angles have to add to 180. That makes this a 110-degree angle. So two angle measures actually gives you three if you use it properly. When we have this, one of the next major things we're going to focus on is the idea of opposite. This is the same opposite from the earlier in this previous chapter when we're dealing with our opposite of a given angle. Because that's what the law of sines is all about. It's all about taking the sine of an angle measure and setting it up as a fraction, a ratio, over the length of the side opposite. Our capital letters are all going to be angle measures. Our lowercase angles are all side lengths, but most importantly, A is an angle. The opposite side of A is going to be A. Capital versus lowercase. We're case sensitive here. That's one of the reasons back in Unit 1 we talked about capital letters for points, because lowercase letters mean something else. So let's go to the next page and we're going to look at exactly how do we apply the law of sines to solve for triangles. In this example, they want us to solve for the information stated on the right side. This h equals means find the measure of angle h. This lowercase g means find the length of the side opposite angle of opposite side to angle capital G. That's this side here. Here's big G, little g goes here. So there's two things that they're looking for us to find. This is all going to be done using the law of sines, which means I'm setting up ratios or proportions and solving. I would start with my angle measure here, but the next thing I'll mention real quick, you should always be given or be able to come up with, find, and let me grab a highlighter here, an angle measure and a side opposite where you have both pieces of information. I have a 40-degree angle. I know its side is a side length of 10. That's what we're starting with. The trig function sine of that angle, 40 degrees, over the side length opposite 10. That's one relationship. I can set that equal to every opposite relationship in my diagram. Since I'm trying to find the measure of angle h, I'm looking at this angle here. I'm going to use the sine of that angle. I don't know what it is, so I call it h. And I use the side opposite, which is 8, in my denominator. Before we go ahead and do anything else, I'm going to mention my answers should only be rounded once. What that means, if I'm looking for an angle measure, I want it rounded to the nearest whole degree. But I'm not going to take the sine of something, round it, then multiply, round again, then divide, round again, and then take an inverse sine and round a fourth time. I'm only going to round one time. In order to do that, we're going to have to do a lot of algebra at the beginning, so we do one thing at the end. Example. This is cross multiplication. My variable is inside my sine function. When I cross multiply this, I get 10 times the sine of angle h equals 8 times the sine of 40 degrees. I am not going to multiply or put any of this into my calculator yet. I'm going to do my next step algebraically to solve for the angle h, and that's divide both sides by 10. That will leave me the sine of angle h equals, just leave everything that you see. Don't simplify, don't try to multiply or divide anything. Leave it as 8 times the sine of 40 degrees over 10. We're real close now, but we're not quite ready to find the measure of angle h yet, because h isn't by itself. I still have the sine there. Remember from last chapter, that's when we use the inverse trig functions. So I have to take the sine inverse on the left. When I do that, sine inverse and sine cancel. That leaves me with h. So I will delete that so we don't get too confused here. But I then have to take the sine inverse of this side as well. So this side becomes sine inverse of all of this in parentheses. 8 times the sine of 40 degrees all over 10. That's exactly what I'm going to put in my calculator. So when I pull the calculator up, I have to type all of this in. First, make sure it's in degree mode. Press mode, make sure your degree is highlighted. If it is, you can quit. If it's not, scroll down and over, hit enter so your degree is highlighted. Go back. I want the inverse sine, so I will do second sine. That automatically opens up one set of parentheses that matches this set of parentheses. Since I am using a fraction, I need to put the entire numerator in another set of parentheses. So I'm going to open up parentheses again and type in 8 times sine of 40. Now, hitting sine opened up a third set, so I have open, open, open. I need to close, closing out my 40 for the sine, close, closing out my numerator. But I don't want to close out my inverse sine yet. I don't close out that third one until after I divide by 10. Now I can divide by 10, close out my last function. 30.94600,686 means I am going to round this to the nearest whole degree and get 31 degrees. That's our answer for the measure of angle h. Now, I know that angle h is 31 degrees. I'm going to use the triangle sum theorem to find the measure of angle g. If this is 31 degrees, 40 plus 31 is 71. 180 minus 71 is 109 degrees. To find G, I'm going to once again use these known measures. Sine of 40 over 10, and set it equal to the variable I'm solving for now. Sine of 109 over G. Cross multiply, I get G times the sine of 40 equals 10 times the sine of 109. I have to divide both sides by sine of 40. I get that G is equal to 10 times the sine of 109 divided by the sine of 40. Again, I am not going to round any of this until I get to this stage. Put it in my calculator. That's going to give me my answer here. I'm just going to type in open parentheses because I'm dealing with a numerator. 10 times sine of 109. I have to close here because every time I hit sine it opened it up. Divide that by sine of 40. Close those parentheses. 14.709. Side lengths I'm going to round to the nearest tenth. That gives me a 14.7 as my side length. I want you to go ahead, use this as an example, and try the next example, the next problem here. It's very similar. I've given you very similar information. So hit pause, try to find the measure of angle M, then try to find P. So for starters, we should have found that the measure of angle M is 81 degrees. We set up our proportion, sine of 64, because that's the angle measure we know, over 10, the side opposite, equals, we're looking for angle M, so we take the sine of it over the length of the side opposite. When we do all of our algebra, cross multiplying and solve, we have to use the inverse sign because we're looking for our angle measure. Put all of this in, we should get 81 degrees. If you haven't tried to find the side length P, please do so now after you press pause. And we should find that that side length is 6.4. This is the proportion we set up. Cross multiply. You'll wind up dividing both sides by the sine of 64. Put everything in your calculator at once and we get 6.4. I'm going to go through one more example. I'm going to go a little bit quicker than I did the first time. This is the example where we have two angle measures that we've been given. In this case, 64 degrees and 28 degrees. My main focus at this point is this 64 degree angle because I also know that its opposite side is 15. So I can set up that as my original proportion. The sine of 64 is over 15 is equal to. Now in this case they want us to solve for D, which is going to be this side here, opposite angle D, and B, this side here, opposite angle B. The first one that we can use that for is D because I already know my opposite angles. So that's sine of 64 over 15 equals sine of 28 over D. Once again, use your calculator. After you've maneuvered everything, we should get 7.8. Next I can find B. First I'll use the triangle sum theorem. That shows me that this is an 88 degree angle. Then I can take sine of 64 over 15 equals sine of 88 over B. Cross multiply to solve, I get 16.7. Go ahead, press pause, try the last problem here, unpause to check your answers. We should get that side J is 43.8 and side D is 45.9.